Okay, today we're going to learn how to find wholes and vertical asymptotes of rational expressions and then eventually equations. And then we're going to combine this with stuff that we're going to learn later on, horizontal asymptotes, x-intercepts, y-intercepts. And we're going to take all these together to make graphs. Okay, or be able to graph rational expressions. So we're first going to start off with wholes. Well, a whole happens when we cancel out an x. Okay? And we're going to do a few examples behind me, and then that'll make a little bit more sense. And we got a little bit of experience earlier in the year dealing with vertical asymptotes, but we know those happen when we divide by zero. Okay? So now we're going to start seeing rational expressions or equations for equal to y or something like this. Okay? Now before you attempt any of these, the first thing that you should do every single time is factor. Okay? So let's factor each of these. So here I can factor out an x on the numerator. Okay, that one was nice and easy. This one here, we can do our ACB method. Take your first term times the last, find two terms that add together to give you the middle one, then factor by grouping. Doing that, hopefully if you struggle with that, look in an earlier video, you're going to get x plus 4, x plus 2. So I can put this over. Okay. Now key thing to keep in mind is that this here and this here are equivalent. They're the same. But notice here that we're multiplying everything and we have an x plus 2 in common. So I can factor out or cancel out an x plus 2. Now we're just left with x over x plus 4. Now, when I canceled out or factored out this x plus 2, we created a whole. Because, think about it, well, let's just first talk about this. So we have a whole at x plus 2. Now we need to find out what value of x makes this thing equal to 0. Because that value of x, we could have plugged in here, and then this whole thing would have been 0. We'd be dividing by 0, and that's a no-no. So we can set this equal to 0. Minus 2, x equals negative 2. So there's a whole when x is negative 2. And all that means is that when x is negative 2, if you plug it into, or substitute it into your original expression, okay, which is equal to this, negative 2 plus 2 is 0. 0 times anything is 0. This whole thing became 0, and we're dividing by 0, and that's a problem. However, here, x could be negative 2, and we're not dividing by 0. So that's why we don't have a vertical asymptote, we just have a whole. Because here it fails, but we canceled it out, so here it's successful, but we still need to account for that. So we get a whole. Then for vertical asymptotes, that's when we divide by 0. So I need to look here, what values of x make me divide by 0? Well, from our vertical asymptote, you just take your denominator, set it equal to 0, because that's telling you the values of x that'll make this equal to 0. So when x is negative 4, this whole thing becomes 0, so I have a vertical asymptote of negative 4. So my vertical asymptote is x equals negative 4, and then I have a whole at x equals negative 2. And we'll talk about later what exactly these are going to look like when it comes to our graph. Right now we just got to be able to find them. Okay? Okay. Next one, try on your own, pause the video, and then come back and we'll talk. So x cubed all over. Okay, so again, pause the video, try it out, and then come back. Welcome back. So first thing that we need to do for all these rational expressions and equations is factor. Okay? So let's factor up here. Well, first I can take an x out. Okay? That's nice. I'm actually going to, and then I'm going to move it down here just to make life a little bit easier. And then here, we could do our ACB method. Okay, now I'm going to bring it down here. So I have x times, that becomes x plus 3, x minus 2. Okay. As far as I could go there. Now here I could take out an x. Okay, and this here is our difference of squares. So it's really important you have all these different factoring methods down because they're all going to come right here. So now this is over x plus 3. Okay. Okay, now you look for things that'll cancel. Well, I have an x plus 3, and you have an x, because they're being all multiplied. Now remember, whenever you cancel an x, you create holes. So now we have holes at x and x plus 3. Now I need to find the values of x that make these 0, because that's when I would have divided by 0 if I didn't cancel them. So x equals 0, x plus 3 equals 0. Okay, this one. So my holes are at 0 and negative 3. So again, back here in the original expression, I could have put in 0 and negative 3, and I would have been dividing by 0. But here, after I make this look a little bit nicer, we have x minus 2 over x minus 3. But here, after you simplify, you could plug in these two values and you're not going to be dividing by 0 anymore. Up here you would, down here you would not. That's why we call them a hole. So up here it's a violation, but here you're fine. Okay, and then our vertical asymptotes. Remember, we're looking for the values that we have to divide by 0 at the end. So I'm going to look for when x minus 3 equals 0. So I have one vertical asymptote at 3, which means if you put in 3 for x, it'd be divided by 0, and then 2 holes. Okay? Okay, we'll try one more together. Again, do the same thing. Pause the video. Try to do it yourself. And then we'll come back together. Okay, so again, try it out yourself, and then we'll come back together. Welcome back. Okay, so again, just like before, we want a factor to start off. Okay? So this one, you can factor either one, doesn't really matter. Which one do you do first? We're going to do the ACB method on the top one here. So you're going to get 2x minus 1 times x plus 1. Okay? Again, this was the ACB method. Okay? Then looking at the bottom of the denominator here, well, this is just a difference of squares. So this is x plus 1, x minus 1. Now I see I have an x plus 1 in common. Let's cancel those out. So I'm left with 2x minus 1 over x minus 1. Nothing else cancels out. But I did cancel out an x plus 1, so that created a hole. So I need to find the value that makes this guy equal to 0, because then in the original expression, the whole thing would have been 0. So I'm going to set x plus 1 equal to 0. So x equals negative 1. So I have a hole at negative 1. Now for my vertical asymptote, remember I'm looking for when I'm dividing this by 0 now, because remember x equals negative 1 would have made this been divided by 0. Now I'm looking for this one. So I'm looking for the values of x that make the denominator equal to 0. So I'll take x minus 1. Make sure you really understand this. Yeah, that might be easy to remember. I just said equal to 0. But make sure you understand why we're doing it. We're looking for the x values that make the denominator 0 because we don't want to divide by 0. Okay? Now we can just add. So you have a vertical asymptote at x equals 1, and you have a hole at x equals -1. So the next video, we're going to talk about horizontal asymptotes and intercepts, and then we can bring them all together to graph.